Hello everyone, and welcome to today's webinar in the CERDP and ESTCP webinar series. My name is Rula Deeb. I'm a Senior Principal at Geosyntec Consultants in Oakland, California, and the coordinator of the webinar series on behalf of CERDP and ESTCP. I will be facilitating today's call. Today's webinar will consist of a brief overview of CERDP and ESTCP by Dr. Robin Nissan, followed by a list of upcoming webinars in the series. After Robin's opening remarks, we will transition to the technical portion of the webinar. Today's event features one presenter, Mr. Scot Bryant from Noblis, who will talk about cadmium and chromate elimination efforts, implementation plans, and strategic roadmaps for 3 DoD depots. Scot will give a two-part presentation. First, he will provide an overview of DoD's 5-year strategy and roadmap, followed by a short Q&A session. Second, he will discuss depot-specific implementation plans, followed by a final Q&A session. Today's broadcast will be listen-only. You may submit questions by using the chat box on the left-hand portion of your screen. You do not need to wait until the Q&A period to submit your questions. In fact, we do encourage you to submit questions well in advance of that session. On this slide, we have provided a few suggestions in the event that you experience difficulties with the broadcast audio. Typically, any delay can be fixed if you refresh your screen or call into the conference line shown here. However, if you continue to have problems, please submit a comment using the chat box in the lower left corner of your screen. With that, I would like to introduce Dr. Robin Nissan, who is the CERDP and ESTCP Program Manager for Weapons Systems and Platforms. Before joining CERDP and ESTCP, Robin worked at Navarre's Weapons Division, China Lake in California. And with that, I turn it over to you, Robin.
Thank you, Rula. So on the first slide, I want to give an overview of CERDP and ESTCP. And CERDP is the Strategic Environmental Research and Development Program. It was established by Congress in 1991, and it's a partnership between DoD, DOE, and EPA. We are requirements-driven, and our goal is to identify high-priority environmental science and technology investment opportunities which can address DoD requirements. We invest in advanced technology development to address near-term needs, and we also invest in fundamental research to impact the real-world environmental management. ESTCP, the Environmental Security and Technology Certification Program, is a demonstration validation program. We invest in innovative, cost-effective environmental and energy technologies, capitalizing on past investments, and look to transition technology out of the lab. And we promote implementation and try to facilitate regulatory acceptance. We have 5 program areas, and they're listed here: energy and water, environmental restoration, munitions response, resource conservation and climate change, and weapon systems and platforms. All 5 of those have ESTCP components, and energy and water does not have a CERDP component. So the second for the environmental restoration, munitions response, resource conservation, as well as weapon systems and platforms all have CERDP and ESTCP components. Today's webinar will focus on weapon systems and platforms. And within weapon systems and platforms are listed some of our major focus areas, including surface engineering and structural materials, energetic materials, noise and emissions, waste reduction, and lead-free electronics are some of the areas that we've invested in. And I'm going to do a little bit more today and talk about some of our corrosion-related investment over the past decade or so. And on this view graph, we basically show that we've invested heavily in corrosion alternatives. And the reason being, some of the things that we utilize to inhibit corrosion are things like hexavalent chromium as well as cadmium. And these materials are hazardous. We want to look for alternatives. We want to get them out of our workforce. And so we've, over the past decade or more, been putting lots of money into various aspects of corrosion control. What we've asked ourselves over the last few years, let's say, is how are we doing? Are these technologies that we're investing in, both at the R&D level as well as at the demonstration validation level, making it into the mainstream and being used? So let's go to the next view graph. And here I've listed some of the projects that we have invested in over the past several years. And these are not all of them, obviously, but there are a few of them. And the reason I have some of these up here is because I think they are technologies that are potentially moving on to the next level and do have a potential to impact our workforce and our laboratories and our depots. And just wanted to say that with the efforts that are going to be presented by Scott today, we've set ourselves a goal, and our goal is to achieve measurable results in elimination of CAD and chromium. So next view graph, sorry. And by setting those goals, we've actually gone out to the community and asked, what are we doing? How are we doing it? What are the amounts and quantities, and what are the processes where we are using these objectionable materials? And are some of our projects or some projects that are coming from other places potentially available to our depots to eliminate some of these materials? So that's what you're going to hear about today. And before we move on to the technical portion of the webinar, I do want to mention that our CERTIP ESTCP webinar series will be continuing, and we have several projects that are going to be presented over the course of the next few months. April 7th is the next one, use of climate information for decision making and impacts research, and then a webinar on chlorinated solvent sites, battery energy storage, quality assurance planning, insensitive munitions, and on and on and on. Finally, on July 28th, we're going to have another webinar in WP on environmentally acceptable alternatives for fast cook-off testing. So with that, I want to thank you all for being here and participating in this webinar, and I'm going to turn it over to Rula again.
Thank you, Robin. It is now my pleasure to introduce Mr. Scot Bryant, who is a Principal Environmental Engineer at Noblis, where he primarily supports CERTIP, ESTCP, and the Air Force Civil Engineering Center. Mr. Bryant has 23 years of experience working with DoD on identifying, testing, demonstrating, and implementing technologies for industrial processes, as well as re-engineering existing processes. Mr. Bryant has a Bachelor of Science degree in Chemical Engineering from the University of Texas at Austin. And with that, I'll turn it over to you, Scott.
Thanks, Rula. All right. So what I'm going to talk about today, Robin gave a great introduction to this, so that we passed. I'm going to hit the project objectives. What we were trying to achieve during this project. I'm going to run through the background, very brief background actually, and then spend some time defining the problem and at least how we decided to define the problem as we approach this. Then I'm going to actually hit the 5-year strategy and roadmap, the DoD level document. From there, I'm going to move on. We'll have a question and answer after that, and then I'm going to move on to the implementation plans at the 3 depots, and then finally we'll kind of wrap this up into a nice package. Okay. So what are the project objectives? Well, Robin had said that we were going to try to set some goals for ourselves, and so project objectives was to develop a strategy and a roadmap to achieve 90 or greater than 90% reduction of hexavalent chromium and cadmium usage at DoD depots. Now, this is a usage of the actual products that contain cad and chrome. A kind of sister goal to that is looking at the emissions, waste streams, and exposure potentials. And so we also not only wanted to get rid of the input, but the output as well. So looking at a reduction of the hexavalent chromium and cadmium emissions, waste streams, exposure potentials, emissions, et cetera, at the depots. Wanted to set all this up over a 5-year period as well. And then the last piece of this was to actually go out and look at some specific depots and develop implementation plans, try to translate the strategy, try to give some very finite actions on how to begin to address the strategy or implement the strategy at a depot. Okay, so real quick background, and this is my why is hexavalent chromium and cadmium horrible slide. Hexavalent chromium, and cadmium both, they're both known carcinogens. They both attack multiple systems, in the human body. And they share a lot of the same areas where potential exposures take place, including welding, coating processes, surface finishing, and with cadmium, just even, bare handling, cadmium-coated fasteners and connectors. So this is, kind of the why get rid of cad and chrome? Well, this is the reason to get rid of it. That and the fact that there are a lot of regulatory drivers that push us toward, reducing and/or eliminating cad and chrome. Kind of grouping these. There's the Clean Water Act, Clean Air Act, EPCRA, RECRA. All of these. Kind of lumped together, and then you have your acquisition regulations, both the 5000.02, the DFAR, that are pushing to minimize the use of chromium and/or cadmium, and then you have international regulations such as REACH and RoHS that actually make it difficult for us to maintain equipment or to move equipment in and out of countries. If they contain cad or chrome. And so all of these, rolled together kind of push us toward trying to get out of the cadmium and hexavalent chromium business. Okay, so talking real quick about defining the problem. And so we started to, as we were doing this, we started to talk about how we're going to define the problem, started to look at how others have addressed this in the past, how they've looked at this area. And what it kept coming back to was we really need to look at this on a process basis. And so that is really kind of the common denominator that we chose as far as identifying the process areas where these materials are used, where cad and chrome are used. And so we came up with a number of different categories or process areas: chromated primers, which includes your aerospace primers and wash primers, chrome plating, cad plating. I won't read through all of them, but you can see we tried to capture everything. We have top coats and specialty coatings for those things that are typically small use, but don't really fit into any of the other categories really well. But this pretty much covers the landscape of the processes that you find out at the depots. Okay. So once we figured out, okay, so we're looking at this from a process basis, but we also need to figure out, well, what's our input to these processes? Because all of these processes have an input and output. So the input to the processes is really what chemicals are coming into them. What are the products that contain cadmium and chromium? And so as we were moving through this and working with the various depots that we worked with, Letterkenny Army Depot, Fleet Readiness Center Southeast, and Oklahoma City, our logistics complex, we began to collect hazardous materials data on products that contain cadmium and chromium. And so putting all this together, and without going into any specifics at any particular base, what we found out from the data, just the data that we collected, is 76,074 pounds of Chrome-6 used over a 1-year period. Now, this is typically calendar year 14, though the information from the Air Force varied a little bit from that. but it was still a 12-month period. So over a 12-month period, 76,000 pounds of chrome. Over that same period, 684 pounds of cadmium. Now, a few caveats. That contained all the data from the Air Force. So this is very, I will say up front, this is Air Force weighted. The Army data only contains the information from Letterkenny Army Depot, and I will talk later about the need to capture additional data from the Army. And the same thing with the Navy. The Navy only contains the information from Fleet Readiness Center Southeast. All that said, the number's only going to if we look at that same time period, the number is only going to go up. The other thing I will say, and I'm going to hit on this some more when I talk about usage and infrastructure, is certain processes might or might not have chemical usage during a given year. And I think one of the best examples of that is cadmium tank plating. The electrodes in the plating bath, you just don't add to that plating bath. You don't add cadmium to that plating bath very often. And so what we found is, there was basically with tank plating, there was no addition to that. There was no input from this. And so that led to well, maybe we need to look at infrastructure as well, and we certainly have to look at the outputs from the process. And so just some thoughts to keep in mind when you're looking at these numbers. These numbers are nice guidelines, but there are some things behind the scenes to think about. Okay, so let's now correlate the usage back to the processes. So I had this nice long list of processes, and we had some usage data. So how does this all mesh together? So looking at this, obviously the largest use is chrome primers. Okay, and in this case, from a DoD standpoint, chrome primers includes both aerospace primers and wash primers, within the Army. But that is by far the largest use of Chrome 6. Going from there, the next largest use is adhesives and sealants. You can think of that as a large usage, or you can think of it as a large collection of small usages. And we'll talk about that a little bit later as we get into how we're going to, the recommendations on how to address this. Also, we look at like CAD plating here. And then, chromate conversion code is kind of surprisingly small, but once again, that goes back to the information that's actually coming in from the hazardous materials reporting. And so is that, did they have to replace a tank? Did they have to add to a tank? So on and so forth. But this is the basic breakout. The next slide kind of talks about some of the takeaways from this. So just so you know, all of the usage data was calculated on actual species of Chrome 6 in the chemicals. So this does not talk about the actual pounds of chemical that was used, actual pounds of primer, but it actually talks about the amount of Chrome 6 that is actually in the chemical, Chrome 6 or cadmium. And so looking at that, what's the top usage? Well, we talked about that, chrome primers, adhesive sealants, chrome plating. So once again, I'm going to go with the Army and Navy data is incomplete. It could change the percentages. I don't think it's going to, obviously don't think it's going to change chromated primers from being the largest usage. Stainless steel welding is not fairly represented here. We don't have information from the shipyards, which is the largest usage of stainless steel welding most likely. And then it is also, one other note about stainless steel welding, it's the largest exposure potential of any of the processes from the Defense Occupational and Environmental Health Readiness System, DOORS. So we definitely want to capture that information as we move forward and continue to evolve the strategy. And I think, like I said, some of the percentages will change, but I don't expect chromated primers to become anything less than the largest usage. And then the other thing that this does not account for, and we'll talk about this more later as we move into especially into the individual depots, this doesn't account for the infrastructure that is dedicated to that process. It doesn't account for the potentially thousands of gallons that are dedicated to a particular process, even if you're not having an input to it over a particular period of time. Okay. So I'm gonna break this out. That last was chromium usage. Here's the CAD usage. As you can see, by far the largest usage is cadmium brush plating, followed by cadmium plating. Once again, you may ask yourself, well, you have thousands of gallons of a plating tank dedicated to cadmium plating. Well, it goes back to what I talked about earlier, is they probably just didn't need to add cadmium. There was just no need to either recharge or change out the tank, and therefore you didn't have input coming into it over that particular period of time. But those are still, the CAD brush plating, CAD tank plating are still the two largest usages of cadmium. Once again, cadmium is calculated based on the actual species in the chemical or the material. It's not calculated by the pounds of a product. And then the same caveats apply here that we talked about for chromium. Navy data is incomplete, and it doesn't take into account infrastructure. Okay, so we've been talking about all of the inputs primarily. There's also some outputs with this. Obviously, you have waste. What we found is coating removal is the largest waste stream for especially for Chrome 6, also for cadmium in some cases. Coatings removal, looking at both solid and liquid waste. And so for solid waste, looking at things like media blasting, where media blasting is not recycled, that can become a huge waste stream, and most of it's hazardous waste. The same thing with liquid waste streams from, say, chemical stripping. It's a very large waste stream. Typically, it could be either drummed or it can just go to a treatment plant, but it is still a very large Chrome 6 waste stream. Emissions. So, all of these processes have emissions associated with them. Now, the one thing that DOT does a really good job of is using engineering controls to keep the emissions within limits. And so, there's engineering controls in place, but that doesn't remove the potential for the emissions to take place. And so if the engineering controls fail, for example, you still have emissions associated with this. And I talked about it earlier too, stainless steel welding is the largest source for Chrome 6 emissions. And it's probably also one of the more difficult of the emissions to control. There are engineering controls to do it, but it's just a little bit more difficult. Exposures, so where you have emissions, you also have exposure potentials. For the most part, once again, engineering controls and PPE prevent exposures. There is not a quote-unquote problem with exposures, but there are the potentials there. And going back again to stainless steel welding and the information from doors, it is the largest source of exposure potential for Chrome 6. And then talking a little bit more about infrastructure, as we moved through this, and I especially need to give credit to the folks at Fleet Readiness Center Southeast, Jack Benfer especially. We started to kind of think about, well, for some processes, infrastructure might be a better reference than usage. And at the very least, it is something that needs to be taken into account as you're looking at what is a priority to begin to address. It really reflects the burden or the liability that they have at the depot. It reflects the potential waste streams that are going to be created from that process. It reflects the exposure potential, and it also reflects the emissions potential from that process, more so than usage data, or even when usage data is very low. So we did start to think about that, and you'll see a little bit more of that when I talk about the depot specific. Okay, so now we move more into kind of a transition from a lot of background information, a lot of the problem definition into the actual roadmap itself. But as we begin to think about the roadmap, or the strategy and roadmap, we're going to start thinking about the stakeholders and who does this impact, and who impacts it, who influences and affects this strategy and roadmap. Well, obviously the depots, from the engineers to the operators, they are primary stakeholders in this moving forward. The lifecycle management centers, all of the system owners, as this, and this is especially true, as this strategy is implemented, whether the implementation takes place at the enterprise level at a lifecycle management center, or it takes place at individual depots, the system owners are prime stakeholders, and they're prime decision makers, and so they have to be rolled into this strategy and roadmap. The laboratories, there's been a ton of work and continues to be a ton of work going on at the laboratories in these areas that can contribute to the implementation of the strategy as it moves forward, so they need to be part of the process. Original equipment manufacturers obviously have to be part of this. You know, in many cases, they still maintain all the drawings. In some cases, they even do some of the maintenance, you know, at contractor site. And so, you know, they have to be part of the solution moving forward into the implementation. And they also need to look at the strategy, and there needs to be, you know, some buy-in ownership there, really from all of the stakeholders. All of the specification owners, because sooner or later, as things are changed, as the strategy is implemented and things change, specifications will possibly change. You know, and this is true of not only specifications, but also other technical documentation. And then corrosion authorities and others. I'm sure there are more stakeholders, and more stakeholders will become involved as the strategy is implemented. But at least these you need to be involved in, and in many cases already have been involved in this. They've been briefed on it. They've seen iterations of it, and so and that will continue as it moves forward and evolves. Okay. So moving on to the actual strategy and roadmap, and I'll just kind of starting off with this. We approach the strategy with basic strategic planning. We approached it from the establishing goals to setting objectives to achieve those goals, to actually looking at the success metrics, and then ultimately defining finite actions that will help achieve the intermediate objectives, which lead to the goals. And so just basic strategic planning process. So going with the objective of the project, we established two goals. Two very simple goals. The first, reduce the use of Cad and Chrome 6 containing compounds in DoD depots by 90% in 5 years. Okay, very, very cut and dried. Reduce the Cad and Chrome, and the second goal was reduce Cad and Chrome emissions, waste streams, and exposure potentials in DoD depots by 90% in 5 years. So same time frame, same percent reduction. One addresses input, one addresses output. In many cases, dealing with the input is going to reduce that output, and so that you know becomes fairly obvious in the flow diagram. But in other cases, you may not be able to especially with things like coatings removal, you're going to have legacy coatings on weapon systems for years, and so you still need to figure out a way to reduce that waste stream, even though you're going to continue to remove hexavalent chromium-laden coatings from a weapon system. And so some of as you'll see, some of the objectives and actions will address those sort of output-related parts of the processes. So now, who do these goals impact? And this was, as we get thinking about, well, obviously it's going to impact all of the DoD depots. it's going to affect hundreds of processes, and it's going to hit many processes at that are going to impact field maintenance as well. So as you look at the primers, the adhesives, and sealants, these all will potentially impact maintenance in the field as well as the depots. Hundreds of weapon systems and their variations, and platforms. As you look across the DoD, and if this strategy is implemented across the DoD, it's going to affect hundreds of weapon systems, and their various variations. And that doesn't begin to describe the number of actual components that are going to be impacted. And then potentially thousands of drawings, technical orders, tech manuals, depot maintenance work orders, et cetera. All of these are as the strategy is implemented, and this is true of projects that have already been run in the past. The drawings and technical documentation has to be changed to allow for use of the products. Okay, so those are the goals and the impacts of those goals. So the next thing we did is we started to think about objectives and the success metrics. So how are we going to break these huge goals down into a little bit more manageable pieces, and how are we going to measure success? And so what we decided to do was, well, so we've defined the problem based on processes. Well, let's set our objectives based on these processes. And so what we did is we actually started to say, okay, let's establish an objective for reduction in chrome primers or cadmium plating or cadmium brush plating. And so we started to look at it in that way. The other thing is, we have data that goes along with that. And so we're able to establish, success metrics based on chemical usage. And, like I was talking about earlier, we may have to start to use a secondary piece of information like infrastructure, but looking at usage is a good start. We know where we're starting from. We can set that baseline, and we can measure against that. And so we decided on, for the input piece side of this, it was going to be, basically pounds of Chrome 6 or pounds of CAD used in that particular process as a success metric. We also set the success metrics for the output side of this for waste emissions, exposure potential. That's also based on pounds. And then we just established the baselines from the hazardous materials data that we had already collected. Okay. So moving down from there, the objectives are still too big. So if you talk about, okay, we need to reduce chrome usage we have to reduce chrome usage in chromated primers. Well, it's still kind of too big a chunk to bite off. And so what we started to do was break this into actions or initiatives. And so the actions are very finite, are finite activities or initiatives that begin to address pieces of the intermediary objectives. So as you look at these actions, and we'll actually hit on some of them here in a few minutes, at the strategy level, these are not individual projects. They're more likely groups of projects. Now, you could do this at very much the enterprise level. So you could have a joint project that addressed an entire area. But most likely they're going to be 1, 2, 3, or more individual projects that are going to ultimately address that action that's going to satisfy the objective. We've tried to tie it to the impacted depots. And then the last piece is we actually went in and tried to prioritize the initiatives or actions, and establish 3 different tiers in which those are going to be addressed. And so each of the actions are prioritized for action within the overall strategy. Okay. So moving on. So what was our, when I say prioritize, what kind of prioritization methodology did we use? I will say we used a qualitative analysis. So this was not a quantitative analysis. We used 4 different criteria. We took a look at impact readiness, and when I say that, I'm looking at how widespread is this, how far-reaching, how many weapon systems does it impact, how many different depots or field units does it impact. So, really, what is the impact there to, potential impact to readiness? Likelihood of implementation really looks like if you find a solution, a particular solution, or any solution, what is the likelihood of that being implemented? Are there barriers to implementation? Are there already projects in place with, for instance, a technology transfer agreement that if they find a solution, it's going to get implemented? Really, what's the likelihood? Return on investment. Now, this is kind of the most nebulous. It is very qualitative, but it looks at, we look at things with a very obvious return on investment to, some of the items that you do it because it's the right thing to do. And so there was kind of that broad spectrum of where projects could possibly fall. And then finally, and certainly not least important, what is the actual impact to the reduction goals? And I think it's best summed up in asking a question in asking or stating the question in 2 ways. I can't reach my goal, and obviously from the data we showed, we can't reach the goal unless we address chrome primers. But you have to address chrome primers to reach the goal. It stated both ways. It becomes very critical and very clear which of these initiatives need to be addressed to be able to reach reduction goals. So we took this, we broke it out based on these qualitative factors. We broke it out into 3 different tiers. So the tier 1 are the critical, the very high impact. They're typically very far-reaching, and they're absolutely necessary to achieve reduction goals. Okay, to achieve that 90 or greater % reduction goal. Tier 2, they're typically not as critical or far-reaching, may not impact as many depots. They have a lesser impact on goals. You may still need to address these types of initiatives to achieve the goals, but they have a lesser impact than Tier 1. In Tier 3, these are typically fairly localized requirements. They're going to impact few depots, possibly only a single depot. They're going to impact few missions, and in all cases, they are not necessary. In almost all cases, they're not necessary to meet the reduction goals. All right. So this next slide, a little bit of an eye chart. I apologize for that, but I really wanted to show this all together instead of breaking this out into multiple slides. So this is kind of the master table from the strategy itself, okay? And I'm going to just hit on some pieces here that have been highlighted. So if you look here at the top, where I have the green arrow, we have the first, this is the goal. This is the high-level goal that's stated here, and this is actually the input side goal. So this is the usage goal, the usage reduction goal. From there, we have the objectives. So if you look here at the objectives, these are all, and you read through these are all based on the various processes, and there are reductions associated with each of these objectives that will get us to the overall reduction goals. And so those are the lower, a little bit lower level objectives. The next column over are the success metrics that describes basically reduction of this over the next 5 years in the depots. Following that is the baseline. This is the baseline on the data that we have currently. As we collect more data, this baseline is going to change as we get the remaining data. I'll talk about that a little bit more later. I've already mentioned it. And then after that, we have the individual actions. And so as you can see here with this top one, we have reduced chromium, use of chromated primers in DoD depots. There's various actions associated with the with that objective. And so there's dealing with aircraft OML, non-OML. There's off aircraft components, and so there's a number of different actions that actually lead into that particular objective. The next column over from there hits on the various depots that are impacted or impact this particular action, and it is broken out by action. And then the priorities. And so I talked just a minute ago about the priorities and how we get there. These are ranked, priority tier 1, tier 2, tier 3. As you can see, just about everything on this particular example is ranked out as a priority 1, with the exception of the last one there, which is ranked out at priority 3. And then the final thing that I want to mention on this, and this is all part of the in the document, is the notional timeline. And so, this is basically the higher priority, the tier 1 priorities. Looking at addressing those immediately. Some of them are going to take an entire 5 years. Some of them might take less. Some of them might take more. But the point is to begin addressing those immediately, and in most cases, the tier 1s do start immediately, and in some cases, there are already initiatives in place that are addressing those tier 1s, and so they've started in, as early as 2011, 12, 13, 14. So, okay. So moving on. So going from that, and so I've now talked. We've looked at some high priority processes. We have looked at this roadmap, and so now I'm going to start talking about the actual initiatives or actions that need to begin being addressed. And so you can look here, the top 3 here, and these were actually just shown on the table, all deal with non-chromated primers, and they're all aerospace primers. All 3 of these deal with them. They are handled slightly different, have different requirements, but all 3 deal with non-chromated primers. The next one in line there is a wash primer. There's actually quite a bit of work going on in that area right now. It's a big usage, especially within the Army, but also within the other services. An alternative to chrome plating. We talked about that as one of the larger usages, but it also has a huge infrastructure footprint, and so that's another one that is a tier 1 initiative. Non-chrome chemical conversion coatings for aluminum. Once again, it didn't show up in the DoD data as a huge usage, and for possibly for the reasons we talked about, but it has a very large footprint, especially from the standpoint of the tank coatings, and then also there's a lot of spray-on coatings as well, and so wanting to address all of those. Also looking at alternative coatings removal processes, and so this one is based purely on the waste streams. This is how do we reduce the chromium waste streams associated with coatings removal. So this is about one of the output sides of the process. And then also the last one, the implementation of engineering controls for stainless steel welding operations. That also addresses outputs. That is not trying to change anything inherently in the welding process, but it is about making sure engineering controls exist to handle emissions and exposure potentials. So moving on to take a look at cadmium. Cadmium is pretty simple. Chromium plating, chromium brush plating, or I'm sorry, cadmium plating, cadmium brush plating. Those are the 2 processes. You're looking at the pie chart that jumped out. By far the largest usages, and those are the 2 processes that have to be addressed to reach the 90% reduction. And I'm going to move on down to the tier 2. So if you remember me saying these are typically less far-reaching, they're typically smaller usages. Just less critical toward meeting the goals in general. So One of those is stainless steel passivation, dichromate sealers and anodizing operations. Once again, this didn't show up as a large usage in either one of these, but there's also typically pretty large infrastructure footprint associated with it. Non-chromated coatings removal alternatives. Now, this addresses coating removal products that actually contain Chrome 6, and it's typically sodium dichromate is what they contain. There was a substantial usage of chemical stripper that actually contains a dichromate, and so this is actually looking at that input side of the coatings removal process. And then non-chrome consumables for stainless steel. Now this is looking at the input side of stainless steel welding, and this is looking at things like palladium and ruthenium for replacements for the chromium within the actual consumables. So either the rods, the powders, the wires, etc. Okay, and we have a whole bunch of Tier 3 initiatives. These are much less critical to achieving the goal. However, some of these are probably also, very much low-hanging fruit and can easily be dealt with. One that I want to point, two of them that I want to point out are the second and third bullets, sealants and adhesives. So if you remember from the pie chart earlier, sealants and adhesives were actually a pretty large usage. But however, as you start to look at that process and break it down, it's actually a collection of a bunch of small processes because there are typically small usages of a whole bunch of different adhesives and sealants, each with a different application. And so to address these, you actually have to address each of the applications separately. That's why I made it into Tier 3. It's just going to be, it's a very difficult one to tackle. You can tackle the smaller applications, but you don't get a whole lot of bang for the buck as you start to do it as far as from a usage reduction. So a couple of more dichromate sealer applications, both for plating finishes and also for black oxide and phosphate finishes. And then you see the specialty coatings. Now the things listed here under specialty coatings are examples. These are things that we found when we went out and did the individual depots for the implementation plans. But these are the types of things that we found, to begin to look at under the specialty coatings area. I think it's worth talking about these last three. So robotic painting to reduce worker exposure. So this is just, and it is purely that. So if you cannot, and this is kind of an if-then, if you cannot get rid of Chrome 6 or you can only reduce it some, well then how do you further reduce your potential exposure? And one of the answers to that is possibly robotic painting. So and then also using that to increase maintenance efficiency. So this looks at the output side of things as well. Reducing emissions and exposure from chromated adhesives and sealants. So if you don't address adhesives and sealants, how can you reduce the emissions and the exposures associated with that? You have PPE, you have other techniques, but how can you at least address the output side of that? And then the last one there is actually looking at cadmium brush plating. If you cannot get rid of cadmium brush plating, can you at least use a technology that is near zero drip, near zero emission type technology to reduce that output side of the process, to reduce the exposures, to reduce the waste. So those are a little bit different than the others, but that's a quick explanation. Okay, so last piece of this I want to talk about is program synergy. So I talked about stakeholders. I talked about impacts of the strategies. So I want to talk about who ties into this really well, and obviously CERTA PSTCP, they sponsored the project, and Robin talked about projects that address this exact area. Toxic metals reduction program, Army program that we've been tied into. They gave us some great information when we first started this. They helped us, folks that work with that program helped us to get into Letterkenny. So, obviously it's very synergistic with that. The Naval Sustainability Development Integration Program, Naval Environmental Sustainability Development Integration Program, sorry, there's a word missing, NESD. It ties in, I know that some of the efforts that are identified under the strategy are, actually being worked under NESD right now, or are future projects that are coming up. Obviously, all of the laboratories, there's efforts going on there that tie into this. There are SBIR programs that tie into this area very well. DLA has, I can think of at least 2 projects they've done over the last couple of years that address areas in the strategy. The Air Force Lifecycle Management Center efforts, we've coordinated with them very closely on several areas. NAVAIR programs, depot-specific efforts. And I know the list goes on. There's a lot of other things that are very synergistic with what we're doing that can both be impacted by and impact the strategy now and as we move it forward. So, and with that, that's it for the DoD strategy, and I'm going to open it up to Q&A.
Thank you, Scott. We're running a little bit late on part 1, so I'm going to try and ask you as many questions as we can in the allocated time. We got a lot of questions. Several of them are from the Naval Air Warfare Center Aircraft Division, starting with, is there a governmental or EPA mandate to eliminate cadmium across the DoD, or are the targeted reductions just at the depots at this time?
So I addressed that back on, let's see, slide 22, and I'm going to actually pull that up here. So you can see there's a memorandum from the Undersecretary of Defense. There is also information in the DFAR, and there is information in DoD Instruction 5000.02 to reduce as much as possible the use of both cadmium and hexavalent chromium. Now, most have focused on hexavalent chromium, but there is a drive within DoD, not just at the depots, to eliminate cadmium as well. So.
Great, thank you. Another question from the Navy. How do changes in the cadmium policy impact the sourcing of aircraft and engine components from U.S. vendor base?
How does the changes in the policy affect the sourcing from the U.S. vendor base?
Yeah. So for example, cadmium-plated parts such as threaded inserts.
Well, so that and that's one of the needs to be able to have to coordinate this with the OEMs. If it's in the contract for that vendor that they are able to provide cadmium-plated components, then unless there has been a change to that contract based on some of this information, they can continue to provide those parts, and there's no impact to them necessarily. As if changes are made to processes, things like fasteners and connectors are typically not maintained at the DoD depots. We don't CAD plate those. If things are changed at the depots that flow, I guess that would be up to the OEMs, then they're going to have to decide whether or not they're going to implement, and that's why things like landing gear, changing the cadmium, changing from cadmium plating to zinc nickel plating out at Ogden for landing gear, all of that was worked very closely with the OEM, and as it was done. So it's a difficult answer, but I think the answer is unless there's a change to their contract, there's not going to be an impact to them to provide the product that they've been contracted for.
Great, thank you. Third question, this one is from a regulator in Nebraska. Does the goal of 90% reduction include the cadmium, chromium in metals and alloys in vehicles?
No. So especially chromium, once you have chrome in the metal itself, it's elemental chrome, and so it's the actual use in the processes where you have the hexavalent chrome. In many cases, cadmium's a little bit different there, but no, it does not. This affects only the maintenance processes and does not attempt to address actual components or structural components made out of a particular metal.
Great, thank you. Are the goals only for DoD depots, or is this project also targeting manufacturers that are developing the products and are being held to mil spec? This is a question from Raytheon.
Okay, so this is for DoD. This is for DoD depots. In fact, the goals actually state reduction in DoD depots. We would love to flow this out, to OEMs and everyone else as much as possible, but this is focused on the depots.
Wonderful, thank you. What time period does the 5-year strategy cover? Is it 2015 to 2020, or is it a different time period? And this question is from Oak Ridge National Laboratory.
Okay, so that's a really great question. So the little table that I showed actually starts in 2016 and flows forward, and it actually includes part of 2021. So we have, and I don't think we haven't actually sat down with Robin and said, okay, when does the clock start ticking? And I don't think it necessarily does. It provides a window, though, for where we would like to address this strategy.
Great,
so,
thank you.
It's not the exact answer that you would probably like, but I think using what I had on the table, which is 16 to 21, is probably a good notional timetable.
Great, thank you. Do the estimates for cadmium and chromium usage include contracted work?
No, does not include contracted work at this time. We did go to at least one depot who had a good bit of contracted work. We did not collect the usage data from that contractor.
Thank you. With that, I'd like to invite you, Scott, to start with part 2 of your presentation, keeping in mind that you have less than 20 minutes.
Okay, I'll try to move through it quickly. Sorry about that.
Thank you.
Okay, so the next part of this, I'm going to talk about the depot-specific implementation plans. We went to 3 different depots: Letterkenny, Fleet Readiness Center Southeast in Jacksonville, and Oklahoma City Air Logistics Complex in Oklahoma City, February, March, and May of 2015. I'm going to start with Letterkenny. I'm going to move through each one of them. And you're going to see a common theme. I'm going to talk about the processes we found. I'm talking about and then move into kind of the recommendations that came out of that, or from the information. So looking at the processes at Letterkenny, chromated primers, conversion coatings, CAD brush plating, some specialty coating stuff, coatings removal, etc. Just moving forward, so looking at this, and so then taking the usage data and putting it along with the processes, this is where we came out. So looking at this again, and no huge surprises here. This is all the processes, but even looking at all the processes, the largest by far is still a variety of chrome primers. In this case, it's wash primers. The second largest is the chromate conversion coatings in tanks. and I'm gonna break this out now by just Chrome 6. So here's the Chrome 6. Once again, looking at the wash primers being the largest usage, chromate conversion coatings in tanks being the second largest. Basically, if you look at that, that accounts for over 90% of their usage, those two processes. So, and takeaways from that, we've kind of already been through that. Those are the two key processes at Letterkenny. Now, this is the world's most boring. Actually, I think it's the second most boring pie chart in the world, and it just simply lays out their cadmium processes. Obviously, cadmium brush plating is their one real issue there. They have a very small usage of a specialty coating that is a silkscreen ink, and it's to get a specific color. Evidently, you can't get that color, or you have not been able to get that color in the past without having cadmium in the pigment. So, and I don't have a takeaway slide from that because that's the takeaway is fairly obvious. Looking at their priority initiatives at Letterkenny, so there's four things that we highlighted as Tier 1. Number 1, address wash primers. Number 2, conversion coatings, and number 3, cadmium brush plating. The final one is actually an output sort of thing initiative, and that is to address reduction of Chrome 6 and cadmium in spent glass media. However, I've also found out that recently, they have started to take their spot samples of their glass media, and it is no longer being disposed of as hazardous waste. And so it is evidently not crossing the threshold for the amount of Chrome 6 or cadmium in it that needs to be, that would classify it as hazardous waste. There's a couple of Tier 2 initiatives, which are just smaller usages, the EMI coatings and non-chrome sealers for phosphate coatings. And then finally, there is the silk screen that I talked about, the silk screen ink that I talked about a minute ago. Now, the last thing I want to do, and I'm going to do this with each of the depots, and I'm going to talk about it in conclusion as well. Letterkenny's already doing a lot of things to address their Tier 1 requirements, or Tier 1 initiatives, not requirements, Tier 1 initiatives. There's been a lot of work done in the past on chromated wash primers. Okay, starting with with some work at ARL, leading all the way up to a very recent project that's just been awarded to the Navy. Actually, it's being led by the Navy to look at wash primers. And so, and there is work specifically going on at Letterkenny. They have some trailers that have been treated with the wash primers. They've set them out in the weather. They've left them out there, and they're going to come back and they're going to further address this. So, so both the TMR project, Army Research Laboratory, and ESTCP has been focused in years past on finding a solution to chromated wash primers. Looking at chromated conversion coatings, Letterkenny is actually involved in a project with the Toxic Metals Reduction Program to look at chrome-free conversion coatings, and that project is moving forward. Letterkenny is actually the demonstration site for non-aircraft applications. So, all right. So moving on to Fleet Readiness Center Southeast, down in Jacksonville. They had a lot more processes and more variations of processes as well. So, it's kind of, running down primers, chrome and cad plating. Conversion coatings, we actually had both aluminum and magnesium going on there, and then aluminum was actually broken up into tank spray-on and touch-up pins. So, and then they use the sealers. They have 3 different uses for sealers there, and they do anodized phosphate coatings and brush and cadmium plating, and then and then they've got coatings removal, stainless steel welding. So a lot of different processes to deal with at Fleet Readiness Center Southeast. So breaking it out by species, breaking it out to look at all the processes and usage. Once again, we're looking at chromated primers being, by far the largest use. It's the, once again, from the overall data, and then as we move through, it is the one thing that needs to be addressed. Breaking that out into just chrome processes, and once again, I have by species underlined here because I want to make sure everyone understands that this is the actual chromated species within it. So this is the chromic acid, this is the strontium chromate, this is the actual species within that product. Breaking this out, this is chromated primers, once again the largest usage, 59% of their usage. Followed up actually by stainless steel welding, surprisingly, as far as largest numbers, and then coatings removal. Now, coatings removal also includes things like deoxidizing, desmutting. So that was rolled into that particular process. And then of course looking at chromate conversion coatings. You'll notice that chrome plating has very tiny usage here, and that is because the tank just wasn't recharged. This is actually, I said earlier, the most boring pie chart. This is actually the most boring pie chart. Cadmium plating and cadmium brush plating are the two processes. Cadmium plating doesn't hit the radar simply because they didn't have to recharge the bath at all. So there was just no input to that process during this particular point of time, and yet there's thousands, and as I'll show on the next slide, there are actually thousands of gallons of infrastructure dedicated to cadmium plate. So this is at Fleet Readiness Center Southeast, this is a chart to look at the amount of infrastructure dedicated to the various processes. And this is broken, this is measured in gallons of dedicated tankage, okay? So the largest here is the aluminum chromate conversion coating, followed by chrome plating, and then followed by anodized seal. But then, CAD plating comes in, pretty soon after that. So this actually looks at the infrastructure and the actual gallons that are associated with that infrastructure. Okay, so what are some of the key processes, take away from the last 3 or 4 slides? So for the hexavalent chromium, chromated primers, obviously, chromated conversion coatings, plating, anodized seal, and then finally the stainless steel welding are all key processes. Fairly large usages, but not just usage, large infrastructure footprints. And then finally cadmium, CAD brush plating, and CAD tank plating are the 2 takeaways there. So what are their initiatives or priority actions? Very similar, once again, a lot of things to address chrome primers. So there's, the top 2 here are both OML and outer mold line and non-outer mold line applications. Chromate conversion coatings for aluminum, hard chrome plating, alternative coating processes. This is dealing with the output. The 5th project down is dealing with the output from coating removal processes, and then of course cadmium brush plating and CAD plating. Moving on to tier 2, once again these are much lesser impact, but looking at a non-chrome anodized sealer, a non-chrome oxidizer, and then looking at reduction of emissions from stainless steel welding operations. And then finally, tier 3 are very small, very localized processes or initiatives. Okay, so there has been and continues to be a lot of work going on, and I've only covered a couple of different areas here. Chrome primers, looking at non-chrome primers on both their gloss finish aircraft and tactical aircraft. This is primarily the rare earth primers. And then there's also, NavAir has a project with ESTCP looking at comprehensive evaluation of non-chrome primers. So, there's a lot of work going on, and continues to be a lot of work going on. Looking at chrome plating, Fleet Radio Center Southeast has been instrumental in progressing the nanocrystalline cobalt phosphorus coatings, looking at that as an alternative there. And so there's 3 different projects listed here as they've continued to move through testing, demonstration, and eventual implementation of that technology. A couple of others that I'm just going to mention real quick. So there is, NavAir is also working on, and chromated primers are also working on aluminum-rich primers. And then also Fleet Radio Center Southeast is looking at citric acid passivation. They've got an upcoming project for that, and then also at zinc nickel as a replacement for CAD plating. So all of this is going on, and if you will, look back, as we look back at the priorities, they're addressing a lot of their Tier 1 and Tier 2 priorities already. Okay, finally, Oklahoma City Air Logistics Complex. Here you can see all of the processes that we looked at. Once again, you can see a lot of the same ones. Not quite as extensive a list as Fleet Radio Center Southeast, but still a lot of different processes with various, with multiple variations. Looking at, now I don't have a total slide on this one, so this breaks it out immediately by Chrome 6 processes, and very obviously Chrome primers is the largest usage there. Followed up by chrome plating and specialty coatings actually. So it's pretty obvious what needs to be, what's going to jump out, and of course that's on the takeaway slide. Chromated primers, plating, and then also chromated conversion coatings. Conversion coatings, once again, the usage according to the data was not huge, but there is a very large infrastructure associated with it. Okay, so looking at CAD processes, so cadmium brush plating is really the big takeaway here. It's by far the largest usage. However, you have this specialty coating, which is a safety paint red. Now, safety paint red is a product called Tempercoat 1000, and come to find out it is actually used in the sprinkler shop. And when I was talking with the folks at Oklahoma City, I believe they were already looking at a non-cadmium alternative to this. Once again, I believe the cadmiums there primarily for purposes of the color. There's a specific color that you get when you add cadmium to the pigment. So they were already looking at a non-cadmium replacement to that. And so even though that's I believe it's a Tier 2 project, it still is already being addressed. So no, I take that back. It is a Tier 1 simply because of usage, because you can't reach the goal without it. So these are the initiatives. The top 4 there deal specifically with primers in various applications and requirements. Obviously, you have to replace brush plating and cadmium brush plating and the safety paint red. And then the final one there is to address looking at Chrome 6 in waste streams with coating removal processes. So this is both physical and chemical coatings removal. Tier 2 initiatives, and so if you think back to the Chrome 6 reduction, if you get rid of all the chrome primer, you get to 90%, according to the data at Oklahoma City Air Logistics Complex. So looking at Tier 2, it's chrome plating, dichromate sealers, and anodizing operations. They're already looking at the trivalent chromium for an alternative on zinc nickel plating. It's an alternative to a chromate seal on zinc nickel plating, and then looking at non-chrome conversion coatings as well for aluminum. So once again, and I have probably 4 pages worth of efforts from Oklahoma City, past and current efforts. I wanted to just touch on a few of those. Primers, they've already done a lot of work on the E3 to KC-135, doing a lot of evaluation and demonstrations with mag-rich coatings, and then also looking at things like electro-deposited E-coat on KC-135 E3 parts. Chromate conversion coatings, so they have already implemented, in many cases, pre-coat on outer mold line and flight controls on multiple aircraft, and so a lot of their spray-on coatings are already moved over to pre-coat. They've got some tank coatings left to address, but they've already made big strides there and continue to work that. Chrome sealers, they're looking at a non-chrome sealer and for anodized parts. So this is a project that's in cooperation with DLA, and then also they're actually in the implementation phase of the trivalent chrome Dipsol IZ264 for zinc nickel plating. So a lot of work going on there, and like I said, this is just a sample of it. There's a lot more that has happened and is continuing to happen at Oklahoma City. Okay, so I'm going to wrap this up with some overall conclusions, and these conclusions actually address both Part 1 and Part 2 of this briefing. This is a dynamic strategy, and I should probably have used, and I actually prefer the word evolving strategy. That it's going to continue to change as new data is received, as initiatives are launched, as we find out more of what we can and cannot do. This strategy is going to change. I think it has to. I mean, I think it has to continue to change to address the needs and requirements of DoD. In many cases, DoD and or the depots have already initiated projects to address Tier 1, Tier 2 initiatives. This didn't necessarily tell the depots or DoD something they didn't know. It simply was an effort to put it all into a single, establish a single strategy to address all of it, and kind of to pull all of this together, and then hopefully it can be addressed on a more enterprise-wide basis. And that goes on to the next bullet. So there's a need for additional outreach and collaboration. So there are a lot of projects out there, a lot of things that are going on, and as you bring in more stakeholders and make it more enterprise-wide, then you can address greater chunks of these objectives and ultimately the goals. We talked about the synergies with the other programs, but I think the strategy really does complement other DoD and service programs, and using the TMR as an example of that. And then the question of, so what do we need to do to, moving forward? What additional data do we need to capture? Well, a couple of things jump out. I think we need some process data from some additional depots. Specifically, ones that kind of jump out at me are shipyards and rotary wing aircraft maintenance. We get a smattering of that at Fleet Readiness Center Southeast, but I'd like to get some information, some data from a depot that's kind of dedicated to that, and then absolutely we have to get the remaining hazardous materials data from all of the depots. That needs to go in so that we can actually establish a better and firmer baseline for both the baselines and for the success metrics. And then I would say, as we've continued to move through this, and I will say, as I've talked to the folks at Fleet Readiness Center Southeast more, I believe we probably need to capture additional infrastructure data, because I do think that is going to, if it is not the end-all type of information, it is very informative, and I think it's going to inform the strategy in ways that pure usage data can. So with that, we can move on to questions for the second half.
Great. Thank you so much, Scott. We have a lot of questions, so let's get started here. Can you please tell us how can original equipment manufacturers get involved with these alternatives and move them towards reduction or elimination of hexavalent chrome and cadmium?
Well, and that's a really good question. So in a lot of cases, they already have. In a lot of cases, the OEMs have done a lot of this work already. I'll think in cases of I think looking at things like citric acid stainless steel passivation. Boeing has had that approved for use for years, and so that's just a single example. I think it's key to the individuals or the groups of individuals that are running specific programs to pull the OEMs in as one of the stakeholders under any individual project, and work very have them be part of the project team and work very closely with the OEM as these initiatives are addressed. And I think that's probably the best way to get the OEMs involved in this.
So much. How will DoD address implementation risks to ensure that each application will be successfully implemented with alternative technologies?
Well, and once again, that's part of an individual project. I mean, that is an inherent part of any alternative testing, demonstration, validation, and implementation project. That there's going to have to be they're going to have to take the necessary steps. Whether it's following the airworthiness steps or whatever it is to get something approved on a particular system and to overcome the implementation risks. And the system owner is going to identify those implementation risks for the most part. So I mean, it's key to have the implementation owners, the process or the system owners involved from the process from the very beginning, buy into actually having a change, and they're gonna help identify the implementation risks. That's not gonna. I don't think that's gonna happen at a higher DoD level. I think it's gonna happen on a project basis.
Wonderful, thank you. Are there summary test reports that are available to non-DoD entities?
Wow. Okay. So there are a ton of test reports that hit areas of this just scattered out across the web in various places. So that's number one. Number two, I'm not quite sure. So Rowan Technologies and CertUp ESTCP have the Assets Defense Database. I'm not quite sure who all has access to that. Keith Legg would be the answer, would be able to provide the answer to that. But that is a fantastic source of information for this area. So that's, but as far as that goes, as far as available, so much of this is inherently for DoD and DoD contractors, and so most of the reports are actually designated in that way.
Thank you. Can you tell us to what extent trivalent chromium is being considered for non-chrome alternatives, and what about cobalt?
Okay, so trichrome is being considered in a lot of different areas. Okay, so it's being looked at as especially alternative to chromate conversion coatings, but also for anodized sealers. It's also being looked at. They're looking at electrochemical deposition or plating of trichrome, and so trichrome is being looked at in a lot of cases. Cobalt, lesser. It's being looked at. Obviously, I talked about the nanocrystalline cobalt phosphorus technology that is being tested, demonstrated, and implemented out at Fleet Readiness Center Southeast. So it's a little bit less. There's some issues with grinding cobalt, so on and so forth, but it is still one of the potential alternatives.
Thank you. Can you please tell us or elaborate on how DoD can use this information and how it can be used to pursue or capture funding to address the identified issues? Also, are you aware of any proposal calls related to this effort? Perhaps Robin can also weigh in on this question.
Sure. So when we sent out the implementation plans to the depots, we actually included in that email some, I won't call it instructions, but some guidance on how to use this information to, when it comes to getting funding. And it is especially useful when if you're looking to put in a CERTIP or ESTCP proposal, responding to the solicitations there, be sure and reference this information. I mean, go back in, and this document is going to be, the strategy itself is going to be published here very soon. The depots in question have already seen the implementation plans. Those will be published here very soon as final. And so go back and reference the information that's there, and make sure that you identify this as part of the overall strategy. Make sure that if it is critical to you meeting your goals, that you identify it as critical to meeting the goals, and that you can't meet the goals without addressing it. Use the document to provide you with backup to when it comes to writing your proposal. Hopefully, it'll also, even if you're not writing a proposal to CERTIP ESTCP, hopefully it's good backup for whoever you are soliciting funds from, whether it's a command or otherwise. So, Robin, do you have anything you want to add to that?
Yes, please.
Yeah, I certainly would. And I'll ask Rula to go to slide 40 for me, because I think there's something there that's worthwhile. But I'd also suggest that there is an ESTCP call out on the street right now where we are asking for proposals. The pre-proposals are due on the 5th of April, and we would welcome proposals in this area. It is a federal call, so industry partners certainly can be part of these projects, but they do require a DoD principal investigator and a DoD site for the demonstration. So we welcome those, but I'll point out on slide 40 that we can't do it all. So we would recommend that alternative sources like TMR, like NESD, like the various Army, Air Force, Navy environmental programs also be used to further this strategy.
Thank you so much, Robin. One last quick question for you, Scott, before we wrap up. Are there opportunities for the military depots to share these results and participate in joint demonstrations or implementation?
Yeah, I mean, absolutely. I think, well, I mean, Robin just really touched on that just now. ESTCP is all about joint projects, joint demonstrations, and I think. Yeah, I mean, I think there's a lot of potential for that, and that kind of comes from when I've talked various times about kind of dealing with things at an enterprise level, pulling together multiple stakeholders to address a very similar problem. So yes, I absolutely believe so, and like I said, these documents are going to be published soon, and so I believe they're going to be distribution D, so they're going to be DoD and DoD contractors, but that still provides for a pretty wide distribution.
Wonderful. Thank you so much, Scott, for a very interesting and thought-provoking presentation. Our next webinar is on Thursday, April 7th, and it will feature multiple presenters regarding a report which highlights expert findings on climate information for decision-making and impacts research. Registration will be open for this webinar soon, so please visit the CERTIP and ESTCP webinar webpage to register for this and other future events. Before we conclude, I would like to remind you that both the audio and a copy of the presentation of today's session will be archived on our webinar webpage in case you would like to refer to them in the future. We would really appreciate it at this time if you can please take a moment to complete the survey that will pop up on your screen at this time. This concludes today's webcast. Thank you very much for joining us.